you for joining the Altium Designer 14 overview. My name is Christine Morris. I am an application engineer for GoEngineer. I will be the presenter today. In the Altium Designer 14 overview, we will take a look at the automated engineering change order process, supplier search links, how you would set up an out job file, as well as linking to a database externally. And we'll also show the MCAD, ECAD capabilities along with the new features of the rigid flex design, embedding components in your PCB, and then the import wizard and the new Eagle feature that has been added to that. So I'll go ahead and I'll get started here. You'll see I have a project open currently in the left hand side. It has source documents, not only my schematic but my PCB and libraries and any of the documents that can be created from within Altium Designer added to it as well. It's important to note that there are 7 different editors within the Altium Designer tool. We have a schematic editor, a PCB editor, a mixed signal simulation and signal integrity editor, as well as an FPGA editor, a library editor, and a full CAM editor. So we'll go ahead and get started. I have open a schematic sheet currently. Say for example, I wanted to delete a component from my design. When I go ahead and delete that component, notice my schematic document changes to a red color, and it lets me know that it's been opened and modified in my projects panel. It's important to note also, if I go ahead and save that document, notice that it is now been modified, but it's still, because the design is in version control, it's not committed to that repository. It's important to note in Altium Designer that in the Altium Designer 10 version, they added built-in version control. So with that, if I go to my DXP preferences under the data management folder, you'll notice here under the version control, they use the built-in subversion. You can also add to or link to an external subversion control as well. Once you have that set up, all it would require you to do is go ahead and connect to a new design repository or create a new one from the link provided below. Once that's done, you can go ahead, use the properties, you can test to make sure that that connection is okay, and then you can begin committing designs to it, just as you see here. Since I've saved this particular design and it's been modified, the next step would then be to go ahead and commit that to version control using the right click and commit option. I'm just going to type in here remove components, so the next person picking up this design would be able to see right away what has changed. Not only that, now that it's turned green, it is been committed back to that repository. So I made that change. It's allowed me to go ahead and commit that to my design repository, and to ensure that that takes place, we can use the system and storage manager to go ahead and look at that timeline. And just as this loads here in a moment, you'll notice all the data, and specifically down below we have the event that happened, the timestamp that it happened, a revision date, as well as the author that went ahead and made that commitment. In this case it's myself, and then the comment also. On the top portion we have all the different file documents. Anything that has been changed is going to denote in red if it hasn't been saved. In this case, it looks like all of the documents have been saved at this point. And over on the left hand side we have our folder structure. The storage manager is where all those designs would reside. At any point in time I can revert back to anyone, I can open up a different version, I can also compare 2 different versions. With that, it's an easy way to find all of those files that you have already created. The next process that we're going to talk about is the engineering change order process. As I had mentioned previously, we deleted that component. If I want to push that information to my PCB, it's going to require me to use my design update PCB document. With that, I can go ahead, and you'll notice once this populates, it has all the information that has changed in this design. It'll show me the action on the left hand side, the object that's going to be affected, and the document that it's going to place that information into. Not only that, we can report the changes as well. So I'll have a running timeline of what has occurred with each of the ECOs that have been created, exactly as it appears in the engineering change order process. Not only that, I have a date and a timestamp to associate with that as well. Once I know that those actions are going to be taking place, I can validate those and then I can execute them. Notice all the green check boxes. Not only that, in the background, my PCB document will appear. So if I go ahead and close this out, notice it prompted me dynamically into that PCB document. At that point in time, I can go ahead and I can continue on with any other design changes that I may need to take place. So say that my schematic and my PCB design are all done. Now maybe I want to go ahead and report and create my documentation. In Altium Designer, there is an item called an out job file. Here you'll notice I have 3 of them set up. I have a fabrication out job file, I have an assembly out job file, and a verification out job file. Each and every one of these have different documents that are contained within them. One thing nice about the out job file in Altium Designer is that each and every one of these documents, once it is created, I can configure them once using the right click and configure button, and once that's done, I can copy this out job file to every single new project that I create in the Altium Designer. So it's considered a reuse item. Also notice on the right hand side, I can output those documents to a PDF format or a folder structure. Maybe that's local to my local drive. Maybe that is an FTP site. Maybe that's an Amazon S3 server. Any one of those items or folders, I can go ahead and generate the content to. When I copy this to a new project, all I will need to do is select the document that I want to output from the drop-down list under the data source and then select the content container. Once that's done, it will go ahead and publish that data to wherever location I have chosen. I can also include variants. If I have different variants, I can include those up above and it will select the variant, and I can use the data source again from the drop-down menu, select the item or variant that I want to use. And it will supply me with that new data. And again, you can see that document is there in the original outputs. So here in this case, my fabrication files might include Gerber files, NC drills. Maybe my assembly drawing has the assembly drawing, maybe a pick and place report or a test point report. And then of course I have my verification that's going to stay with the project. Normally it might be my design rule checks or my differences reports for components. All of that data can be comprised right within the Altium Designer. Not only that, we also support linking to a database. So if I just go back into the schematic, if I go ahead and do File New and select the database link file from the option here, notice it opens up a connection source. And the database that I can connect to, I have an Access or an Excel database, but before we go ahead and connect to it, let's show the different providers that we can use for the connection string. I'm just going to click on this Build button, and under the Providers tab, you'll notice maybe I have an SQL server or an Oracle server. Anything that is ODBC driver compliant, I would be able to connect to within the Altium Designer. I have an example of a Vishay capacitor access database that comes with the tool, so if you have it installed, you can most certainly navigate to it. And let's just go there real quickly, and we're going to go to our database library folder and choose the Vishay MDB file. I'm going to go ahead and open that, and I'm going to connect to it. Notice immediately there's 3 different tables that come in. I have a ceramic, electrolytic, and tantalum. With that, if I look at the table browser, notice all that information comes right in from that database link file. Not only that, since I've linked to it, I can also add it to my libraries panel, and I can place directly from that database as well. In this case, it hasn't been added, but what I can do is I can go and install that database right into my libraries panel. And I'll just go back to that same exact location that I just was, and I'm going to add that database library. And I'm going to change my filter here to the database library, Vishay capacitor. Open that up. Once I close this, the dialog box then will show those 3 added tables that I just connected to. And let me just open that up again, and let's go down to that bottom lower portion. It will populate with that, and if I expand this a little bit further, you can see that place item is there. I can place any one of those capacitors directly from the database, and it's loading the component. So I'll go ahead and change that very, very quickly. Once I have that on my cursor, if I do a right click, I'm going to go ahead and open that up, and notice all of those parameters are right there and available for me. So I can very easily go ahead and see that parameter data as it is provided there. But maybe I don't have a component database that I have externally and want to link to. But I would love to see that supplier data in an existing component. We have a way of getting that done as well. If I double click on this schematic component, you'll notice I can go ahead and I can copy that comment. And that comment field in Altium Designer is always going to be the manufacturer part number. Once I go ahead and I put this into my supplier links, I do a search, it will update with that exact component and all that parameter data that I would like to see. Here all I need to do is do a right click, add supplier link, and once I do so, if I right click, I can open that up, and all of those parameters now exist in my schematic or in my library if I choose to open up the library and place them there, and I would have them available for use in my bill of materials. And just to show you how that looks, if I go ahead and I open up my bill of materials, I will see the supplier down at the bottom left corner in the all columns, and then it will show the data that is available to be supplied with that actual solution. So these are all the information, and you can see right here in my bill of materials, if I expand this a little bit further, I have a subtotal for the pricing, I have a unit price, I have the stock. This is the exact one. There's 0 stock, so this is a really good analysis to show, especially if I'm doing design to cost. You can see I can choose that currency. Maybe I want to make a run of 400 of these. It will subtotal that exact amount for that component. In this case, it's $1,675.80. And I can go ahead and pass that bill of materials off to my procurement department. They can then begin either looking at lead times to get the stock in place, or maybe I want to go ahead and just replace the component completely. I can identify that quickly through that bill of materials that is reported in Altium Designer. Not only that, we have the Active Bomb. The Active Bomb is a great way as well to actually provide this information. It's the same as you would initially see in the bill of materials as you generate that normally. However, in this case, I can also go ahead and target an actual price that I want to include. Maybe my full price is $200 or $400. This is the actual price, and this will include any of the components that I already have supplier links attached to within my design, and you can see there's a few of them here. If I click on any one of those, it will supply me not only with the manufacturer and all the data, but it'll give me the pricing and the availability. In my case, it's already letting me know that there's not enough stock and I've missed my targeted price. I don't have an actual targeted price, but I can increase my quantity as well, add that to the details. It will update with that information and put it here in that Active Bomb. All you need to do is to create the new Active Bomb is go into your File, New, and select the bomb menu from the list. In this case, there's already one listed, but it would be right here underneath that database link file. So that is the Active Bomb. Now we're going to switch gears just a little bit, and we're going to talk about the MCAD, ECAD capabilities. In Altium Designer, you have the ability, and this is the same design that we've been talking about, to see your design in 3D. provided you have the step models attached to the libraries. It's important to note that the Altium Designer 3D implementation is not only a viewer, it is also an editor. It abides by all of the design rules within Altium Designer, and those are listed here. Specifically, if you have component clearances, you might have a minimum horizontal clearance or a minimum vertical clearance. This is where you would comprise those in the design rules prior to running your DRC check. What it will do is it will flag based on those clearances to know whether or not you are in constraint with the design rules. At that point in time, if you are, it will go ahead and show those in bright green on your screen. Not only that, you also have the ability to go right inside the internals of the board. As you can see here, this is the actual copper on the top layer. These are the through-hole vias, and then the bottom layer. If I found that there was a short in my DRC, errors or reports, I could go right into the internals of the board, delete that, and it would automatically remove it for me in 3D. So you can imagine all the errors that you would then go ahead and be able to fix immediately just based on seeing the 3D capabilities. Not only that, I'm going to switch over and I'm going to show you a library component. Maybe for the very first time you're bringing it in the Altium Designer tools, your model, and you need to attach it. In this case, I'm already in 3D mode, but I would use my Place 3D Body menu. I would select the extruded shape, go ahead, and you can see there's always going to give it an identifier. That's going to be the name, the top or bottom side that it's going to reside on, a mechanical layer that I choose, and then at the bottom I can add snap points to allow for alignment. I also, when I click the embed step component, I can select that step model, and then once I bring it in, and I'll just cancel here, it will come in. If I'm in 3D, it'll show that exact model, but if I'm in 2D, it will show in a hat shape, and you can kind of see that my color on the background is a little bit, but this is the hat shape, and if I highlight it, it's in gray. Going back into 3D mode, then I can quickly and easily align that to that center of that component. In this case, I have a snap point right at the center, which is very easy to see there, and it allows for easy placement of those models and making them fit. So every single time I use this component in the future, it will have that 3D manifestation associated with it as well. Not only that, we have an enclosure that was built in SolidWorks. And if I zoom in here, you can see here, this is the enclosure, and this is recessed down. This is a very simple board, of course, that was designed in the Altium Designer tool, but just to show you how that 3D checking occurs against the design rules, I'm going to move this over. Notice when I am trying to align this top cover that there are collisions, and specifically in the Y1 area. Up at the very top, notice how that isn't aligned properly, and if I go ahead and I just select that cover, I can go in and I can double click on it, and I can change that opacity so I can see through it. This allows for quick and easy alignment features. I can then go ahead, I can do a right click, I can see those violations, each and every one of them, with that enclosure. So it allows me that fitment checking that I would expect. Not only that, say I'm done and I've resolved all the issues, at this point in time, then I can go ahead, I can save out that actual board or printed circuit board as a step file format. I can use my file save as, I'll save that, it already exists, I can overwrite the file, and notice the options. I can export the 3D bodies, which are basically either my step bodies or component bodies that were built within Altium Designer, my pad holes that are going to be significant, and then if I want to put a component suffix, I can add that as well. Once I click OK, it goes into that same location as my project. I can hand that off to my mechanical designer. The last item I have to show in the 3D options is this is a board that has a stack up of 5 different PCBs. And you can count them here. I have 1, 2, 3, 4, and the 5th one is the little modular board that I just showed and exported. Imagine if you are designing a product for the very first time, especially if there are 5 different boards that are part of that design. Notice how these alignment holes, you can see those immediately and whether they will align properly or not right here in 3D. And let me just go ahead and rotate, but you see that mounting hole? I can see all the way through to that workspace, which is in that gray color, all the way, and to make sure that there aren't any issues when I'm looking at that. Not only that, I can also look at the clearances. Make sure that they aren't impacting any portion of those areas that are considered the through holes for that particular pin. And imagine these heights, they're pretty large here as far as the heights for those components. If this were going in an enclosure, I would want to know that immediately. And this is one way of identifying if I were to place an enclosure in the PCB editor, just as we had seen previously, it would flag me with any of those constraints that might be in violation. So that is the MCAD ECAD portion of the Altium Designer and how it would be used quite easily within the Altium Designer environment. I'm just going to collapse a couple of these other projects, and I'm going to go ahead and we're going to talk about the latest features within the Altium Designer 14, and that includes the rigid flex design. Here is a board that you traditionally wouldn't normally create in the Altium Designer. There is a rigid portion, which are the circular pieces of this design, and then we have a flex portion, which is right here in the center. When the new features were added to the Altium Designer, it required the layer stack manager to be improved to include the flex stack up as well. I'm going to go ahead and open this up, and for those of you that have used the software previously, this may look similar to what you are accustomed to seeing. The only difference is down at the bottom. Now if I'm going to add a new stack, I can determine whether or not that stack will be flexed by just checking this flex box here on the right hand side. Every time I add a new stack, it will be given a new name. I can choose whether it's going to be flex or not, and then up above I can define each of the layers that will be included in that stack up. In this case, you can see all the ones that exist for the rigid portion of the design, the type of layer it will be, whether it's signal or the dielectric or an overlay, also the materials, the thicknesses, the dielectrics, the pullbacks, and if there is an orientation that needs to be defined, that can be included as well. Each of those stack ups will be comprised of everything that you would normally make up, and notice on the flex portion there is only 3 layers enabled. It's important to note when you're going to do rigid flex design in the Altium Designer platform that at least 1 layer is common between both the rigid and the flex. And you can imagine it's almost as though that rigid portion is just an extension of that. And you would then go ahead, once this layer stack up manager is comprised the way you expect it, the next item would be to go ahead and plan out that layer. Under my view menu, I have a board planning mode. This allows me to define where that rigid region stops and where the flex portion starts. In this case, I have split lines defined. These are the yellow little dotted lines or dashed lines. How you would place those is through the design, define split line. It will go ahead and add a cursor to, or add a cross shape to your cursor, and you would then be able to drag that right along. Once you finish that particular line, then you can do a right click in that command, and that would then allow you to separate those regions and define whether it's going to be rigid or flex through the drop down menu. And you can see I have done it for both those sides, and there's also some bending points, and we'll show that in just a few moments as we go ahead into the viewing of the 2D. Once I have those defined as far as where those regions reside, then I can go into my 2D mode. I can place my components, wire and round up all of those nets, And at that point in time, I can also include my 3D models. In this case, I'll go to the 3D mode, and you'll see immediately when I go into 3D mode, and let me just go ahead and change this around a moment. Let me just go and scroll, and you'll notice here all those components, bodies and things are placed automatically. Not only that, I have the flex portion as well. And you can see that that is just an extension of another layer that is already built in to that rigid portion. If you can see that outline in a little lighter gray there, that would define that extension of that rigid portion that goes all the way across. If I go into single layer mode here, you can see it even more readily, where those regions reside and where that mid layer to bottom layers, top layers. So you have a great visual inspection of each of those layers that reside in that actual stack up as well. So that is within the 3D viewing. We have also improved the PCB panel here. If I open that up, on the layer stack option, that is another option that's been included in the PCB. If I go to the flex, you'll notice I have different bending angles defined as well. So if you could imagine in 3D, because we have the editor, now we can add bending angles to allow you to see what a product would look like if it were manufactured with the components. In this case, I have multiple bending angles. I have the bending angle, a radius, an affected area, and a fold index. If you could imagine previously, if you had a ribbon cable, that would be how you connected multiple PCBs in a design. A header would connect to a ribbon cable and then extend through and then connect to another PCB on the other side. So in this case, those bending angles are exactly what would be used, and when we go ahead, and I'll show you this being folded up so you have an idea of what that would look like. Notice right here, those bending angles that are in, it's wrapping that flex portion right around into that PCB, those rigid portions. And you can see here very, very quickly where those fold lines are as well. If I just zoom in a little bit, and you can see the fold lines there, the fold line of where it's going to extend into that rigid portion, as well as the routing on the flex portion also, and any of those components that would be then placed there. So you have the capability of expanding this and exporting it out, sending that across to, you know, your design mechanical engineer so they can continue on with any of the features that they may see valid to put in as far as an enclosure. And that would be how you comprise in Altium Designer a rigid flex board. Basically set up that layer stack manager, go into your planning mode, then go ahead and you can place and route just as you do any other design in the Altium Designer toolset. And then after that's done, you can go ahead and add those 3D models to that PCB library, and your end result would be shown here, provided you put those bending lines and so forth within. We also have support for an actual embedded component. I'm just going to go ahead and I'm going to open up a PCB library and show how you would define that particular cavity for an embedded component. And here, as I open up this library, if we just go ahead and add, and let's just take one of these standard library components for a moment, and you'll notice here this is just a general capacitor. In the Altium Designer, now under the place solid region option, I can go ahead and I'm going to define a space that is a little bit larger than my actual outline of my component. Notice immediately when this is actually comprised, it comes in as red as a fill. Now there is a new option to define a cavity definition. Immediately it will be placed on a mechanical layer. I can choose any one of the mechanical layers that are enabled on my board, and I will give it a height as well. In this case, I'll just give it 1 mil. Once I do that, it will immediately go onto that mechanical layer 1. And if I go into Shift S and mechanical layer 1, it is comprised on that layer, and you can see the outline there in the pink color. With that, once I have that defined, then all I need to do is go ahead, right click, and I can place that component body. And I'll just do it here on this physical PCB, and you can see I'm going to place it on the top layer. But if I wanted to, I could hit the tab key. I could choose this mid layer because I want to recess it into that board. Notice immediately it will go ahead and show that. Not only that, you'll want to make sure that height, notice here it's showing me a violation. I am now intersecting with that top layer of the board. So my component height is larger than the area that is between the layers. So that is one of the things when you're defining that cavity, you want to ensure that that height is appropriate. Otherwise, you'll see violations here. But this is an example of how it's recessed into the board. And again, you can do that on your rigid board just as you would place any other components. The only key being, if you hit the tab properties, it will show that drop-down menu. You can select the layer that you want to embed it to. So that is an example of how you would embed layers within embed components within the Altium Designer platform. Not only that, we also have support for, and let me just go in here, and I don't have my importers defined there, but we have support for the Eagle importer as well. And that includes design files from the 6th version of Eagle. So if you are wanting to import Eagle designs, you most certainly have that capability through our import wizard, just as I show in there under the file new. And when you install those importers for the very first time, Eagle will come in as part of that. You can walk through the wizard, and basically it will ask you specific questions about how you would use that and what you want to go ahead and have translated into the Altium Designer automatically through this translate and import wizard that is built into the file menu. So as an overview of what we have done today, there's quite a bit of information, but I just want to go back and summarize for everyone. We have talked about the Altium Designer, the automated engineering change order process, the supplier search links, how you would set up an out job file, as well as a database link file, how the MCAD ECAD capabilities are in existence within the tool, as well as setting up rigid flex design, placing embedded components, and then support for the Eagle importer. So all of those are comprised right within the Altium Designer tool set. And that is all I had for our overview. But I want to thank you, and if you have any questions, please feel free to reach out to us here at GoEngineer, and we're happy to get that information that you need and those questions answered for you. Thank you, and have a great day.